In this video, I want to have a look at parabolas and chords. So a chord is just a line segment that joins 2 points on a parabola together. So if we have the points P and Q that lie on the parabola x squared equals 4ay, then the equation of the chord PQ is this here. So the first thing we're going to do is go through and prove that that is the equation. So to do that, we're going to use the point gradient formula, which is y minus y1 equals m outside of x minus x1. Now to find m, I'm just going to do this off to the side here. To find m, we've got our 2 points, so we're going to go y2 minus y1 over x2 minus x1. So we're going to have aq squared minus ap squared over 2aq minus 2ap. Now, if I factorize out a as my common factor in the numerator, I'll have a outside of q squared minus p squared. And in the denominator, I can pull out 2a, and I'll have q minus p. Now, numerator and denominator both have an a, so I can cancel that through. And the numerator, this bracket is also the difference of 2 squares, so I can factorize that out to q plus p, q minus p, over 2 outside of q minus p. Now, those q minus p's, they cancel out. And I'm just going to end up with q plus p over 2. I'm just going to rewrite that the other way around so it's in alphabetical order. Not that it really matters. So that there is our m. So we can now put that up here into this formula. And our x1, y1, it doesn't matter whether we pick the p or the q as our points. We can do either. I'm going to pick p. So subbing that in is going to give us y minus ap squared equals p plus q over 2. Outside of x minus 2ap. Now I'm going to expand this side out, so I'm going to leave my y minus ap squared equals, I'm going to rewrite this term as just a half outside of p plus q, because that's going to start making it look a little bit more like what we've got down here. And expanding that out, I'd multiply that by x, and then I'd multiply this by this term here as well. So I'd have minus p plus q over 2, or half p plus q, either one, times 2ap. Now the 2 and the 2 down the bottom are going to cancel. So I'm going to end up with a half p plus qx minus, now I've got this p plus q and then multiply that by ap. So I'm going to now expand that out as well. I should keep writing this down. So I'm going to have y minus ap squared equals a half p plus qx minus ap squared minus apq, expanding that bracket. Now I want to move all of this over to one side of the equal sign, so I'm going to move all of this over this side. So I'm going to end up with y minus a half outside of p plus qx. Now if I add that ap squared onto both sides, it's going to cancel out with this minus ap squared over here. And then I'm just going to add on my apq, and I'll have equals 0. So that's us proving that this is the equation of the chord joining 2 points on the parabola. All right, so let's have a look at an example. So our example asks us to consider the points P and Q on the parabola x squared equals 20y. We're asked to find the coordinates of P and Q, where lowercase p is 2 and lowercase q is minus a half. And then we're also asked to find the equation of the chord. So for that one, we're going to use this equation here. So the first thing we need to recognise is the form of this equation, that if we've got x squared equals 20y, we can find our focal length. So we know that 4a, that coefficient of y, has to be equal to 20, which means that our a is equal to 5. So this is solving part A of this question. We know that p is going to have coordinates 2ap, ap squared. So we know that lowercase p is 2, and we know that a is 5. So that's going to be 2 times 5 times 2, and 5 times 2 squared, which is going to give us 20. Now for q, we're going to have the same sort of pattern, so 2aq, aq squared. But in this one, our q is minus a half, so the a is still 5 though. So we're going to have 2 times 5 times minus a half for our x coordinate, and for our y coordinate, we're going to have 5 times minus a half squared. So that's going to simplify down to minus 5 and just 5 over 4. All right, so that's part A, so finding the coordinates of those points. So for part B, we still know that A is 5, and we have this equation here. So A is 5, P is 2, and Q is minus a half. So all we need to do for this one is fill in all of those values into this equation. So we're going to have y minus a half outside of P plus Q. So that would be 2 minus a half x plus APQ. So 5 times 2 times minus a half is equal to 0. So we want to go through and simplify all of that. So we're going to have y minus. Now we're going to have 2 minus a half would be 1.5 or 3 on 2 x plus the 2 and the half are going to cancel, so that'll actually not give me a plus, it'll give me a minus 5 equals 0. And if I go through and multiply everything then, or if I simplify first, I'd have minus 3 over 4x minus 5. If I multiply everything by 4, I'm going to have 4y minus 3x minus 20 is equal to 0. And I can rewrite that so it's in proper general form, so moving everything over to the other side. So I'd have 3x minus 4y plus 20 is equal to 0. So that's solving part B of that question. All right, the next thing I want to show you to do with chords is something called the chord of contact. So to do this, I want to first show you what a chord of contact is, and then we can have a look at its equation and some of its properties. So a chord of contact, if we have a parabola, so it's got equation x squared equals 4ay. If we pick an external point, for example, down here, we're going to draw 2 tangents from that point to the curve. So one of them, and I'm going to do my best to draw this straight, one of them is going to come up about here, and it's touching just there, and the other one is going to come off this direction. So we've got 2 tangents drawn from that point. So this is our external point. We've got 2 points of contact. If we join those together, the chord that they make, that chord drawn in there, is called our chord of contact. So let's have a look at those. Let's give these some names. Let's call our external point P and give it coordinates x0, y0. Let's call these ones, I'm going to draw it down here because I can't reach in there, call it x and y. So we're going to say x has coordinates 2ap, ap squared, and y has coordinates 2aq, aq squared. And they have those coordinates because we know that they lie on the parabola. Right, so what we're going to do, we're going to find the equation of that chord. So we know from what we just did earlier in the video that any chord has equation y minus a half p plus q, x plus a p q equals 0. So we also know some other information as well, and that's that they intersect at p0, y0. And from our earlier video on tangents, we know that the point of intersection of 2 tangents has coordinates, a outside of p plus q, not pq, p plus q, a, p, q. So that point of intersection has to be, in this case, our x naught, y naught. So what that means is that x naught has to be equal to a outside of p plus q, and y naught has to be equal to a, p, q. Now I'm going to take this one and rearrange it. So I'm going to have x naught over a is equal to p plus q. So what I'm going to do now is substitute both of these 2 things into this equation because we know that the chord has to have this equation, but we also now know these relationships as well. So what that's going to give us is y minus a half. Now we had p plus q. In this one, we're going to substitute in x naught, so times x naught over a, and that's multiplied by x. And then we've got plus apq, but we know that that is y naught, and that's equal to 0. So we're going to make this look a little bit nicer. So we're going to have y minus, now this is going to give us x naught over 2a plus y naught equals 0. I'm going to move my x's over the other side of the equal sign, and I'm also going to multiply everything by 2a, so I'm going to do this all at once. So I'm going to have 2a outside of y plus y naught is equal to x naught. Now this formula is on your formula sheet. It's the equation of the chord of contact from an external point, x naught, y naught. All right, so I want to have a look at one last example for this video. We're asked to find the equation of the chord of contact drawn from the point 6, 2 to the parabola x squared equals 12y. So we know that it's going to be in this form. Our x0, y0 is going to be our 6, 2, and we need to figure out what our a is. So our a is going to come from here. So if we have 4a equaling 12, then that means that our a is going to be 3. So we can substitute those 3 values into this equation. So we're going to have 2 times 3 outside of y plus y naught, which was our 2, is equal to x times x naught. Our x naught was 6, so that's just going to give us 6x. So we're going to have 6 outside of y plus 2 equals 6x. We could divide both sides by 6. So we're just going to have y plus 2 is equal to x, or if we write it in gradient intercept form, y equals x minus 2. So that's having a look at parabolas and their chords.